You ready for this?
Yeah, I think so.
You think so? Good, because we started streaming.
Oh, wait. Oh.
Oh, yeah. Hi, Twitch, and all viewers from ByteConf. We are super excited to be speaking on behalf of ByteConf and talking today about machine learning from the browser using React. I personally don't have machine learning experience. He's definitely the ML expert of the two of us. I'm your React expert. Cheers to React fans out there. So today we're going to be talking about 5 ways to do machine learning from the browser with React. We are both technical evangelists at AWS. My name is Nikki.
And I'm Nick.
That's right, Nikki and Nick. Here for you.
The dynamic duo. So, yeah, obviously machine learning has generated a lot of buzz around it recently, and for good reason. It provides a lot of value to developers who are able to leverage it. However, a lot of that progress has been more on foundational technologies for building models. And so a lot of developers that want to be able to use it quickly and easily haven't been able to do so. So we're here today to talk about some really amazing services that allow developers to leverage their knowledge of APIs to use machine learning services to power their apps and do lots of really amazing things. So super excited to be here, and let's get started. So,
okay, tell us what machine learning is.
yeah, exactly. So let's lay the groundwork. So machine learning is a class of software solutions and algorithms that enable you to take data, perform multitude of different types of computation on it, and ultimately result in some sort of model or schema that will result in how your software is going to behave around different parts of data. Now, that's really complicated, and across lots of different subject domains or data types, these algorithms are very different. They all have very nuanced swishes and toggles you can play around with that result in different performances. But ultimately, if you always break it down, you can have a process where you start with data, and after performing some sort of function on it, you're going to be resulting in having insights. And so that's really what everyone cares about, right? What are my inputs? What are my outputs? And what is the function that I can plug my data into to be able to receive that? And so that's the wonder of the services we're going to be talking about today.
And if I was like a developer and I wanted to get into machine learning development, what would I have to learn and know?
Yeah, so most foundationally, like frameworks such as MXNet, TensorFlow, these are classes of programming frameworks that enable you to leverage languages like Python, and now commonly some are available in JavaScript, but other languages of that, like Python, that enable you to define a schema, collect your data, run an algorithm that is typically has a very long computation time to build out a model, and then you have to learn how to take that model, which is its own sort of beast in itself, and build a service around it to be able to do something called inference, where you now feed it new data and it will do some sort of behavior based on that. So there's a lot involved with machine learning. But
I don't know if I have time for that.
yeah, no, a lot of people don't. And more importantly, if you're not solving a novel problem or building a novel model that has some very specific use case.
That's never been done before.
Exactly. A lot of those models exist out there, and you can probably leverage one of them without having to reinvent the wheel. So that's what we're here today to show you, how to leverage the insights that you can get from machine learning without having to reinvent the wheel here.
Brilliant. It's exactly what I want. So, machine learning APIs. Have you ever heard of such a thing? So AWS has amazing machine learning APIs that you can take advantage of, again, without knowing any machine learning development. How is this possible? I know, I was asking myself the same question like a couple weeks ago. And what does it cost, and is it easy? So it's super easy to take advantage of. We've shown you here how to use every single one of them in React from JavaScript. And obviously, if React is not your flavor, you can totally copy our JavaScript and paste it into almost any different application. And how do you do it? We're going to show you how to do it. Well, we're going to go step by step with each one. And what does it cost? So the value that you get from these APIs is absolutely incredible, but we've actually noticed that all of them are part of the free tier. The free tier is something that AWS offers if you are just signing up for AWS. There are things that you get in the first 12 months free, and then there's things that are indefinitely free. So these are all part of the first 12 months free, and they're actually all in our GitHub. So we've created a GitHub for this project. We will post the link to the GitHub in the chat, and it tells you how to get started with our slides and also our actually React demo that we're going to show today, and also what the free tier includes for each one of the APIs that we've used for you here. So it's an incredible offering, and you can try it out today on AWS and get a ton of stuff for free without paying a cent.
Yeah, and to give a quick explanation of the order of magnitude of some of these free tiers. Like, for example, for Translate,
2 million.
2 million separate requests of translation are covered under the free tier. So needless to say, any sort of experiment you want to be able to run, or even putting this into a production app, like a pretty solid amount of your traffic in the beginning, or all of it in most cases, will be completely covered under the free tier. So you don't have to worry about being charged for these services in the beginning.
And some of them are really fun. You're going to see. We're going to play with a few of them.
Definitely excited to get into it. So
moving on.
Yeah.
Tell us about Comprehend.
Yeah, so Amazon Comprehend, wonderful service. Essentially, what it aims to do is to give you deeper insights into text data. And so that can take many different forms, but some of the features that have been most prominently used are its abilities to extract the sentiment of the text. So this has lots of different use cases, right? So you want to see, oh, are these reviews for this movie or this restaurant positive or negative? You can now do that programmatically using an API. Alternatively, sometimes you want to automatically detect maybe the language in a given passage of text. Comprehend enables you to do that as well. So super powerful. I'm excited to showcase how that gets used. But before we jump into that, I think it's really important to showcase at least a little bit about how this is done manually.
It work?
Yeah, so under the hood, language models are their own entire class of like computational theory.
Yeah.
They're covered under the blanket of NLP, natural language processing.
Yep.
And people spend their entire lives studying this, performing research on it. Some people get PhDs exclusively in natural language
Linguistics
processing.
major over here.
Yeah, there you go. So there's so much nuance to it, but ultimately performing these things like sentiment analysis involve not just assessing individual words. While some words we know are really mean or nice or positive or negative, a lot of the important part of that comes down to like context, for example, right?
Right.
And so understanding these complex interactions of words afford themselves to a whole class of models exclusive to NLP. So a lot of very involved work. Even though I like to think I'm an expert in ML, anytime I look at some of the body of research, it always blows my mind. So really excited to be able to showcase how you can leverage this all from an API. So let's dive a little bit into the code and show people how they can use Comprehend using a React app.
All right, so in our React app, let's actually take a step back and walk them through the React app. So we just have, we're just using routing here, and each route is named after the service that it's showing. So each component, so we're going to go to the Comprehend component, and if you load up the homepage of this React app, you're just going to see all of the options. We're just going to go to Comprehend. Oh, I'm not running it. One sec, let me run it. Now I'm running it.
Yeah, so while this is booting up, I'll talk a little bit more to the structure of the app that we have for today's demo. Essentially, we have a smorgasbord of all sorts of different APIs that do these wonderful things, and they're all existing as their own standalone single pages.
Yeah,
so
you can actually copy any one of these components and drop it in your app and use it. I mean, you might not want our front end because it's not the best, but
we opt for simplicity, so it's easier for you to understand how we've coded it than necessarily.
So in this component, you have a couple things in state. You have the text and then basically the results. You're getting three things back: the message, the sentiment, and the score. The message is going to tell you success or failure. The sentiment is going to tell you if it was positive, negative, or neutral. And then the score is like how confident it is that it's that sentiment.
Yeah.
So we just have an on change to basically take the text, and then we're sending it to Comprehend. Here's where we instantiate the Comprehend service. Oh, and let's take a step back for a second. We are using Cognito to get our AWS credentials from the browser. If you've never used Cognito before, it's a really easy way to get credentials from the browser. There are many different ways to do it, but Cognito for me is the easiest. So I just created an identity pool, or it's basically if you click federated identity in Cognito, you can create an identity pool, and then you can use it to get unauthenticated credentials or authenticated credentials. And you can give your Cognito identity pool an IAM role that has access to different services inside AWS. So for example, you could even have an app and the unauth users can only hit, Comprehend, but then the authenticated users can hit transcribe, for example.
Yeah, so most people are used to leveraging API by having their credentials either stored in another file. You can write them directly in there, which is terrible practice. But
terrible, you don't want to do that.
Could you just explain quickly how Cognito enables us to perform API requests without explicitly having like our key listed directly in here?
Yeah, basically. So when we instantiate Cognito identity credentials, we give it our identity pool ID, and then it's going to give us back credentials for the unauthenticated IAM role. So if you really did not want your unauthenticated IAM role to have a ton of AWS access, you maybe would have like your IAM role have no permissions on it. And then when they log into your app and authenticate, then maybe you want the authenticated access where they can do everything in your account. In the purpose of our demo, we don't have authentication in our application because we didn't actually need it because it's just a demo. So we're just using the unauthenticated IAM role, and that's the one that has permissions to each of the 5 different services in our application.
Awesome. Yeah. So so especially when you want to be able to call these APIs from the front end and you don't have some sort of proxy API to authenticate users, Cognito is super valuable for that.
100% valuable. So this is a very basic component. We're basically just setting the state of the text when it changes, and then we are sending text to comprehend. So this is the call. All of these calls, by the way, are in our AWS SDK JavaScript. I specifically go to the API reference when I'm looking for an example of how to make the call, and I can show you where to find that as well. But basically, we just render a component, and then let's actually take a look. So this is going to work, right, if I say something?
Yeah, so it's set up right now to analyze the sentiment. So you can...
I am really happy to be speaking.
Yeah, there you go. So we would obviously expect this to be some sort of like happy or positive sentiment, right? So we have this little bit of text. We send it in.
Yay, it worked.
Awesome, it worked. So again, that was an API call. So it sent a request using that text that Nikki wrote in there, returns a response that we expected. It's positive, it's happy. And actually, as a part of comprehend, we can see the confidence that it had in these different sentiments. So we can scroll along here, and it says shows positive as 0.64. These are between values of 0 and 1, and the closer to 1 it is, the more certain or more confident the program is, or the model, that this is the true sentiment of the text.
Should I try something negative?
You could, yeah. There you go. Yeah. So let's see what it thinks. Okay.
It's definitely positive that it's negative.
Yeah. So we can see the positive value dropped all the way down to near 0, and negative is near 0.73. So fairly confident. If we actually scroll along here, there are other. Obviously, every sentiment is not positive or negative at the extremes. Sometimes it's mixed, sometimes it's neutral as well.
You have a little bit of neutral in there.
Yeah, I'm the ML expert, not the React expert, so I wasn't able to get this to look as pretty as I would have liked. But you can actually see how confident it is in all 4 of these different categories. And so we just give examples with, like a short little sentence here. But why don't we open up like a page on Wikipedia, like just a random page, and that should be pretty neutral, right? Like the about section of a Wikipedia page, maybe like AWS, and we can paste that in there and see what it returns. Just grab a whole blob.
All right.
Yeah.
You got it. Neutral.
Yeah, there you go. So this is as expected, and I'm glad to see that Wikipedia doesn't have, like emotionally charged passages for information.
I really need to use this to just analyze sometimes my text messages to make sure that they're neutral.
Yeah, so once you have this data returned from the API call, you can really do whatever you want based on that. You could use this for maybe prefacing like a hate detection filter, or like servicing like compliments to people, maybe in like a feed where you want compliments or positive comments to pop up more.
Or just seeing if your users are generally enjoying their experience on your site by what they're saying.
Yeah, exactly. There's the uses are sort of endless for this type of thing.
Totally.
Yeah, so that's comprehend in a nutshell. And let's give it like one last look, and then we'll move on to the next API. Yeah, so next up is
Polly.
Amazon Polly. So what's the first thing you think of when you think of Polly?
A parrot.
A parrot, exactly. So it's aptly named. And so Polly enables us to synthesize speech from text. So input text, magical function in the middle.
This one's my favorite.
And then audio comes out the other side, just like a parrot,
You
right?
can have full-on conversations using Polly.
Yeah, although I've never met a parrot that can read, but,
No, but if he's got Polly running on his machine and I've got Polly running on my machine, we could just be talking in Polly voices all day.
Exactly, and I think we can show that in a little bit, right?
Yeah.
Awesome. So let's see. So first,
how hard is this? Because I want to know.
Yeah, so talking to a parrot may be easy, but having some sort of high quality text to speech program is extremely difficult. You know, like it's almost a joke how bad text to speech has been for very many years, where you put text in and it reads it syllable by syllable or word by word, and it doesn't sound natural at all. Like no person would ever talk that way. But over time, we've gotten a lot better. Like the research has
missing like
improved.
The inflection and the intonation of speech.
And there's a lot of really specific regional things, dialects, accents that all play a role in making believable and high quality text to speech. And so that body of research is very large, much like natural language processing. But instead of starting out with the trying to enable sentiment, which is sort of like a text to text element, you have this hard part of trying to assess, well, how good is this audio that I just produced, which is its whole own problem of scoring your success of your machine learning model. But we have some really powerful features behind Amazon Polly, some wonderful research scientists that have helped make some great features, and we're going to show you what that looks like today. So let's see.
I really like talking with Polly. I am going to quit using my voice.
Oh, I sincerely hope not. But yeah, so that's just a brief sample of what Polly looks like. And we have a lot of knobs you can actually tune under the hood directly through those API calls. But as you can tell, those are not MP3s that are just stored locally or playing. Those are API requests sent out with the text that Nikki was writing. And she's going to explain a little bit more about the magic behind how you can get those responses back with the audio.
So this component is doing a little bit more than the last one. I have a actual component installed from NPM React Audio Player, which is that little audio player that the sound goes into. So when I send the text to Polly, I can send different voices. So you'll watch if I actually change this to Russell, which is the Australian male voice. There's a lot of voices.
I am Russell.
It sounds different. There's a lot of different voices in English, so a lot of different dialects. We have Australian, British, English, and then there's several other languages that we support. So if you speak those languages, you can translate them.
Yeah, I think for every given language and gender and regional dialect, not everyone yet, we will get there.
I brought up the voices here. There's a lot of them.
Yeah, so if you check out the Polly documentation, you can see the name codes for every one of these very many different speakers that we have available. So
sometimes we only have them though in male or female. So like Gerard, I think that's how I say it. English, Welsh. Let's see what he sounds like actually.
Yo, what's up?
Yeah, so we have something for everybody there to make sure that the voice suits whatever your need may be in your application. So voice ID for speaker is one of the many knobs we can tune. What are these other values here under speech params?
Okay, so I basically gave it the output format, MP3. It supports other output formats if that's what you wanted. The sample rate in hertz, and the voice ID. The text I edit right here to be this.text, which is what we're typing in, this.state.text. And then we basically just instantiate Polly. We give it the speech params and the instantiation of Polly. And then we run get synthesize speech URL. And then once we get out the URL, we just set the component that is the audio component, the one that's installed from React Audio Player. And then basically it just plays. I have it set to autoplay. So that's why it does that.
Cool. So
it's
yeah,
very simple.
Pretty straightforward. It may seem like a lot at first, but ultimately, just with one API call, you start with that text data, and you can get back the raw MP3 to do with as you wish, right?
Yeah, and there are other parameters that you can play with. This is just the simplest way to do it, and the parameters are listed on our JavaScript SDK.
Awesome. Yeah. So Polly, really great tool. Obviously, messing with audio files or trying to apply a machine learning model to text and tune them can be really tough, but for the problem set of just taking text and making it audio, Polly seems to be pretty strong and able to enable you to get off the ground really quickly. So
And you can do really fun things with it. So.
Yeah, we have battles in the office sometimes where we
Yeah,
just refuse to speak, and
yep.
we'll just have our own favorite voices, and we'll talk to each other just using Poly.
It really happens.
Yeah,
It's crazy.
And as you saw, it's so fast, right? Like as soon as you hit submit, within under a second,
Under a second for sure.
you have it back, and it's already playing your audio. So it's a hoot to play around with, but there are a lot of serious applications you can use it for as well. So.
Totally. But I just like to mess around. Next one.
Yeah, next up we have Translate. So this is obviously a very common and very valuable use case. You have text in one given language, and you want to be able to translate it to another language, right? Typically, this is reserved for apps you may download on your phone or web apps that exist out there for you to type into a GUI. But here we can do this programmatically over an API, which is again super valuable.
There are many actual applications out there that are using Poly and Translate to basically help you learn languages. So I know Duolingo is one that definitely takes advantage of Poly.
Yeah, I mean, that's a great point. Like with how easy it is to start leveraging these different APIs without even knowledge of machine learning, you can actually chain together some of these to have really complex sort of applications that deliver these crazy sorts of use cases, right? Like, let's say you take a picture, you get the text extracted from it, you translate it, and then read it out in audio, right? You can do all of that with
Duolingo all the time.
Yeah, just chaining APIs together, and you can have the entire backend of your app essentially covered. So
okay, so how's this one working?
yeah, so this also falls under the class of natural language processing problems, much like sentiment analysis. So I think this is probably a bit easier but simpler of a model than let's say sentiment, where context is a really hard problem to understand, right?
Yeah.
To understand whether something's positive or negative.
Well, you have to parse the language syntactically and then break it down for understanding and meaning.
Exactly. So with translation, there are bodies of example texts for when this model is trained for specific words that may be extremely unique to one language. So it's a more straightforward or simple problem to solve, but it still doesn't mean that it's easy to be able to make that backend, collect all of that data, run the training algorithm. So simple translation over an API is still an extremely valuable thing.
Good thing Amazon did it for me.
So yeah, let's dive into that. Take a quick look.
All right, so here's our translate component. So again, very simple state. We have text and results. We have an onChange to update the text in state, and then send text to translate. So these parameters are, you're giving it source language, so translate English to Spanish.
Yeah, and so these are actually parameters you can throw over the API. So, if, for example, you wanted to be able to programmatically assign translation or conditionally translate things, you can feed it a different base language. I believe actually comprehend has a method that enables you to detect language, right? So let's say you don't know the language, you could chain together comprehend and translate to detect the starting language. And let's say you always had a destination language, like a travel app, for example, for people in a certain region. You could know that it will comprehend will automatically detect the language, and then you feed that into translate to the destination language, and you have this wonderful simple app with 2 APIs.
What should we translate?
I don't know. Let's just say I'm excited to chat with the audience during ByteConf.
Oh, if I could type.
We don't have that as a service yet.
It's not going to be able to translate this.
Well, ByteConf is a proper noun, right? So let's actually see.
Oh, wow.
Yeah, so I don't speak Spanish, so I'm not going to...
Estoy emocionado de charlar con el público durante ByteConf.
Yeah, there you go. So I can't speak to exactly how accurate that is, but I'd imagine that a sentence
That's accurate.
Yeah? Okay.
Yeah.
Awesome, yeah. So obviously proper nouns, it detects that it's a proper noun and doesn't try to, break it down into constituents.
It's definitely the more, it's not the, casual form of saying it.
Yeah, so that's actually...
It's the formal form.
That's one of the largest problems with direct translation in that body of research. You can have the exact same meaning conveyed, but how casual something is, or slang, things like that make it a little more difficult.
Yeah, we're always adding new words to the English language every single day. And the way people say things differs from actual grammar, right? And other things like that, which make it difficult to translate.
Yeah, languages that have more common sort of ancestors, let's say if we did Spanish to Italian, for example, that may have a much more direct translation. But even then, it's translation is a very manual process a lot of times, but this API does a really good job of automating a lot of it.
Totally.
Yeah, so translate, pretty simple, but very powerful, especially when you chain together with some of these other language, some of these other APIs. There's an API that we're not going to be showing today called TextTract, which is really
it's a
cool.
new one.
Yeah, it does OCR, which stands for optical character recognition. Essentially, what that means is that it pulls characters off of an image or detects characters and words in an image, and you can chain those together with some of these to be able to create end-to-end apps with just a handful of APIs. So
Yeah, so if you had like a PDF document, like you can think of like a W2, you can basically extract all the keys and values and save them in like a database or do something with them.
yeah, so it takes text and extracts it. So we called it TextTract, right?
Really creative.
Really creative, but easy to understand. So yeah, that's about it with Translate. What do we have up next?
Transcribe. So this component is actually a little bit more difficult, right? Because at first I had to record the sound, and then I had to buffer it, and then give it to transcribe. And transcribe actually needs it to be in an S3 bucket. So first I had to send my audio to S3, and then I create a transcription job with using the S3 URL. And then once I've done that, I have to actually check to see if my transcription job is done. And that sometimes doesn't happen always immediately.
And for a little bit of context there, S3 refers to Amazon S3,
Right.
which is our storage solution for files. And once it's on there, it's easier for the Transcribe API to be able to call it. So the first part of the process, uploading your file to Amazon S3.
Yep. Recording it,
recording it, right?
then uploading to S3.
Yes. And to be able to upload to S3, can we use Cognito also for that as well?
Yep.
Awesome, yeah. So with Cognito authenticating our user, that gives them the credentials to upload the file so that people can't spam our server and upload all sorts of random stuff to it. And then once it's there, that same Cognito user pool enables us to then transcribe that audio file into text, right?
Yep.
Awesome.
That's exactly how it works.
Yeah, so under the
How
hood...
does it work under the hood, though?
Glad
Before
you-
I show the JavaScript.
Glad you asked, yeah. So this is extremely complicated. So you're working with raw audio data, and you have to, somehow convert this into text. And so when you say like, hey, like it's hard to understand someone, can you try to, with the combination of hard of hearing but also watching their lips, try and interpret what they have, these algorithms don't have access to the context of being able to see someone's lips to be able to sort of figure that out.
Or watch their body language.
Exactly. And so they need to be able to work directly off of that raw audio data to try and properly determine individual words to chain together. And it involves a huge corpus of data that you have to collect. You need to try and get all of these different edge cases.
To train the model to actually understand possible edge cases for transcribing audio to text.
Exactly. And so when you think about it, right, like this model should be able to take any audio that's spoken to it at all and extract words from that. And so when you're training your model, that involves having training data that has all of these different words, and you try to rearrange them in all different orders. So it's a very involved task. It involves, not even on the order of gigabytes, even larger than that of training. So it's a very, very complicated process. It takes a lot of time, takes a lot of money to train. But with this model, once it is trained, you can leverage it. And that's exactly what Transcribe's API enables you to do.
Let's leverage it.
Yes, let's take a look.
So let's go to the code for a sec. So I mentioned that I'm again using React Audio Player and also another component recorder to just record the audio. So if you look at my component down here, so what I'm actually doing is I'm recording, and I have a button that obviously shows stop recording or start recording. And then once it records, it uploads it to S3, and then it'll actually play for us in the browser using the same React Audio Player that I used for Poly, just so that we can see and hear what we recorded. Rather hear, not see. And then once it's been uploaded, you can get the transcription, and that's going to run for a little bit because it's actually I'm using recursion to keep calling it until it's completed. So this last function, get the transcription. So let's take a step back. Let's go back up. So when I stop recording, I put the object in S3 using this call right here, and I give it public read access so that we can actually play it without any credentials. And it is a WAV file. Then I'm actually going to start a transcription job, and I'm going to give it the S3 URL that I just got from uploading it to S3. And then I actually have to give public access to the transcript object so to make sure that we can actually get the transcription. And because when it's done, it's going to dump the output into S3.
Yeah, and for that S3 URL, could you explain how you get that in the computation there? Is that a part of the response from the upload, or how are you getting that?
The S3 URL?
Yes.
So it's generally the same. It's just s3.amazonaws.com/mybucket, which is transcribe output.js. Really creative, I know. And then all I have to do is give it the key, and the key is just what I named the file.
Okay, cool. So that's nice
Just
and easy.
test.
Yeah.
Again, my naming sucks, but
There you go. So it's overwriting the same file each time in this
Exactly.
instance. Okay, cool.
I could do something more clever, like make a random number and add it to test, or add it to something more descriptive of what it is. But yeah, it's just overwriting the same file because I don't need to do a ton of transcription or have different ones in there. But the key here is that I have to call the transcription job to see if it's in progress still or if it's completed. So you see this if statement right here. So if it's in progress, I basically set a timeout of 5,000 milliseconds, and then I recall it again to see if it's done yet. And then when it's completed, then I grab the, first I give public access to the transcript object, and then I grab the actual transcript and I display it, which is what's happening right here.
Cool. So it's not a pub sub method where you can just, set it up on the cloud and then it'll automatically return it. You need to basically pull the endpoint, and while it's in the process of processing, it'll have a different return code. And
yeah, you can use a while loop, a do while, or you can use recursion like I did, whatever your preference is. So let's see it work. Okay, so I have this in steps here to make it really easy to understand, since this is a more complicated component than the other ones. Okay, so you're gonna talk. Ready?
Okay. Super excited to be giving a talk here at ByteConf.
Really creative. Okay, so when this play button.
Super excited to be giving a talk here at ByteConf.
So that's what we recorded.
Okay.
Now, we're gonna get the transcription. Well, this is gonna spin a while because remember, it's just recalling itself every 5,000 milliseconds to see if it's done. And then when it's done, it should just display.
Okay.
It's definitely a slightly more complicated component, but it's still possible, and you are more dependent on S3. So in this case, you need to have an S3 bucket where you're pulling the audio files from, and then also you're dumping the output to. If you do not give transcribe an S3 bucket to dump the output to, it just dumps it to one that it creates by itself.
Cool. And we mentioned before that there's a very high amount of utilization that's covered under the free tier here. S3, obviously another service, but I believe that's covered under the free tier as well, so you don't have to worry about incurring costs, right?
Right.
Yeah. Cool. So
it takes a second. It's a longer job.
Yeah.
As you said, it's probably one of the more complicated models.
Yeah, exactly. And in like the context of models being complicated in air quotes, because complicated involves a lot of things.
Bike off.
Bike off, yeah. So I actually threw it a little curveball there. I said the proper noun, and much like I said before, in this model, it's probably never heard the audio for that word before.
That's right.
But it did a pretty good job of picking words that are pretty similar, right? It didn't
Yeah.
just like go haywire and spit out complete gibberish. So this
It's pretty
is
good.
Yeah.
It pretty much almost got it exactly.
Yeah.
We need to add ByteConf to its vocabulary.
Yeah, we'll have to chat with the researchers on the team, make sure that this recording gets put into the training set for the next batch of retraining. So yeah, that's transcribe. Super powerful and takes a really nuanced, complicated concept and distills it down to be able to use that. So
Let's go to recognition.
Yeah,
it's probably like the coolest one.
Rekognition, I know the fans love Rekognition. So
I'm a fan.
Amazon Rekognition, essentially what it enables you to do is take images and recognize things in them. And what this really means is that we have a model that takes all of these different objects that we've trained it to be able to detect, and it will be able to classify your image and hopefully match it up with one of them, and it will tell you how confident it is.
Objects, faces, even celebrities.
Yeah, so lots of different things, very powerful, all within this one really simple framework. But before I get into showing how that works,
Yep, tell us how it works.
first is image recognition. So you have lots of different things that can be in pictures, right? You can have a picture of just an object on a standalone desk.
While you're always talking, I'm going to grab some fun objects that
Oh,
we can
okay.
test out.
Awesome. Yeah, so you can have a standalone object, or you may have a picture of a landscape, for example, right? And inside one of those pictures of a landscape, you may have many different objects. Ultimately, this comes down to how you train your model. When you have a given image, what are the labels that you assign to it? And there's a lot of nuance here. You can have something called semantic mapping, where you take individual images that are isolated to just show those concepts, and then you can have multiple matches in a given complex image. There's a lot of work that's being done in here, and this provides a lot of different values. But ultimately, in today's example, we're going to be showing you a bunch of different images, or we're going to be taking a bunch of different pictures using our webcam, and we're going to see what Rekognition thinks about all of them. So,
I got some fun objects.
Yeah, some cool objects we have laying around here in the studio.
Okay, before we play with these, let's talk about the component. So walk us through what you're doing.
Yeah, so starting from the top, we have some NPM modules or
You're
components
using
I found.
React webcam to just grab the picture.
Yep. And so I'm using Cognito as well to be able to authenticate and make these requests. And so let's scroll up quickly to see the prems. So we have a few things here. We have image result message, which is going to be the status of the API request, result labels, which are going to be the labels that Rekognition returns. So hopefully it's guesses correctly, but regardless, I'm excited to see what it thinks is in there. And image source is just going to be the local location or the in-browser location or in-memory location of the image that it's returning, so that we can mess around with it.
So he handles the capture of the image using the webcam, and then he sends the image to Rekognition. It looks like you also convert it to a buffer.
Yeah, so this is a little bit of like pre-processing. So Rekognition specifically accepts data in the form of a byte array. I think there are others
or
as
an
well.
S3 object.
Or an S3 object, yeah. So if you already, let's say for example in your app, have images being stored on S3, it's very straightforward to be able to just pull that directly. But if you want to do this all on the front end, right, you can get it directly from a webcam or an upload. We use the webcam in this example. So
so then you just call detect labels.
yeah, so we instantiate the Rekognition client right here. We are binding it to this component. And we have this Rekognition detect labels method call. There are many method calls in Rekognition. You can do things like detect faces in particular, which will return the coordinates to make bounding boxes. Or in our example, it's the general model where it will just detect whatever is in the image. So we call that. We are going to collect the labels that it returns. And if it errors out, obviously we catch that message.
And so in render, if the result message isn't equal to nothing, so we got a result back, then we basically map the labels out in a table so you can see the name of the object that it thinks it detected and the confidence score.
Yeah, and so this is actually something you can play around with. You can change the threshold for confidence so that you're only getting results that, let's say, the model is very confident in. You can also change the number of labels you get back as a maximum. So you can really fine tune this to exactly whatever your use case is, so that you're not munging through a ton of data on the front end unnecessarily, or you only are returning things that it may be very confident in. Or maybe you just want to get a better idea of what images are uploaded, and you can return everything, right? So
okay, I don't want me though. I want to test the Rubik's cube.
Okay, all right. So let's give it a whirl. So we have the webcam over here that is going to.
Okay, we need to face the wall so we can just hold this up. Ready?
Yeah.
Detect labels.
Okay, let's see what it found.
Okay, so it detected my hand as being a human. Rubik's Cube!
Wow, okay, awesome. Yeah, so, your arm was in the shot, right? Like
it
was holding it, and that obviously has a very unique signature because it was very confident.
I think it thought that was a staircase.
Oh, I could see why though, right? Because I didn't explain this before, but in image recognition, essentially what it does in an image is that it squashes all of these pixels down into a, 1 by X array. And it finds those relationships between those pixels. And so in stairs, much like, this wall that we have behind us, you have these panels with these dark gaps between them. And so it's really interesting that it found that.
Okay, this is my buddy Flames.
Flames? Okay,
Yeah.
What is Flames? Phoenix?
Looks
like Griffin?
Yeah, he's a Phoenix.
Okay. All right.
He's my favorite guy.
Let's see what Rekognition thinks of Flames.
I can't, not have my hand in it. Can I sit?
Yeah.
Oh, wait. Hold on.
We got Flames a seat.
It's going to detect the typewriter maybe, though.
We'll see.
Dragon lamp.
Dragon, there you go.
Is there a lamp in the picture? There was. There's a lamp.
Oh, yeah, it's either there or behind us over there. So
yeah, there's a lamp in the corner.
Yeah, so 98% accurate, or 98% confidence rather, that that's a dragon. So
let's do one
pretty
more.
cool. It definitely, the training set obviously may have not had Flames this
I'm having
particular.
way too much fun with this.
It may not have had this exact image, but it was able to extrapolate or interpolate within the body. All right, I'm gonna try and get out of the shot as much as possible. All right, we got it. All right, so interestingly enough, it thought
Scale.
it was a
Word.
scale.
Well, this is like an old school Word document. Like,
Yeah, a typewriter. So I'd actually be interested to see if you turned it, maybe.
if I turned it on its side.
Yeah, so this is a huge other concept in image
But I
recognition.
can't be in the camera. So let's
Yeah.
go back. Let's get the lamp out of the camera.
But
Okay.
no, maybe turn the keys themselves, or yeah, on like an angle, maybe.
How about that?
Yeah,
Okay,
great.
go.
Okay, let's go.
Whoa. Yeah, really can't detect it.
Yeah, so
Sports car. Maybe it has never seen a typewriter before because like they're not really used anymore.
well, typewriters, come in many different shapes and sizes, right? So like even if it has one in there, it may not have been of this form. Like I know typewriters typically have like paper standing up in them, or maybe they look different.
How about water bottle?
Okay, yeah, let's try that out. It's so tough to not be in the photo at the same time. Human, person, cylinder. Okay.
Cylinder.
Purple. So it also detected color. Aluminum. Well, I'm surprised it can detect that maybe from the gloss
Wow,
or the
that's
shine. So yeah.
Home decor.
Home decor.
That's right. My water bottle is home decor.
Athleisure, right? So one of the big things with models is understanding the scope. Thankfully, this one model is able to detect everything from very specific topics, like it was able to detect a dragon before, to much broader things like
Wow,
home
okay, I
decor,
did
material.
Apparel, clothing, human face, sweater. Look, it got my sweater.
Yeah.
Lighting. Wow, look how many different things. Selfie. That was a selfie. Wow, I didn't know it could detect selfies.
Yeah, and so it's important that not every image can only be classified by one accurate label, right?
I want you to know that it thinks we're at a bar.
Well, we have this, this counter here, right? So, recognition can handle multiple different labels, and it doesn't exclude another one just because it knows one is very likely to be true. So, like, all of these things here all on the top that it's very confident in are true. So, super valuable. You can get many different types of insights without needing to have different API calls or different requests. Just send one request with the image, and you'll get all these labels and confidence values back.
It's only 57% confident that I'm a woman, but it is
Well,
74% confident that you are a man.
It's interesting. I'm curious at how the model is trained with like multiple people in a given image, right?
Yeah.
So obviously this.
Oh wait, female is higher. I missed that one.
Oh. The model will perform best if you're trying to assess one very specific thing, if that's the only thing in the image. The more that you enable to be in the image, the less confident it can be in any one of those things, although we work every day to make sure that the model is more accurate. But that's just
Super
kind of
cool. I could like play with this all day.
yeah, that's just the nature of image recognition. But again, Rekognition, the service, enables that to be as streamlined and easy as possible.
I just want to keep playing with this. Can we try your laptop? Let's try a laptop. Let's see if we can detect a computer.
Yeah. So
Okay, ready?
let's see.
Hide.
Yeah. Might detect my fingers. We'll see.
Computer, electronics, laptop, PC, and it did detect
Display,
you.
screen,
Human,
monitor.
person, you're behind it.
Great.
That's
So
really
yeah, you
cool.
can see a use case where you sort of control for a lot of the other variables, and it gives you a much more accurate response. So yeah, that's Rekognition. So Rekognition we showcased here with images, but Rekognition works for video as well.
It does. It also has a content moderation feature. So if you wanted to use it to moderate photos to like basically avoid people uploading inappropriate things to your site, or use cases like that where you needed to moderate the content and make sure it's appropriate or age level appropriate even, you could use it for that use case.
Yeah, so we used the text labels here, that method from Rekognition, but there are other ones that solve very specific use cases that it'll be much more confident and easy for you to implement when it comes to trying to understand your images. So
That is 5 ways to do machine learning from the browser.
yeah, there we go. So I know that was a lot of info. We threw it all at you pretty quickly,
We
but
did.
we will have all of that code available up on GitHub in this repository. We tried to design it to be as modular as possible so that you can just take it and plop it right into your own project. But ultimately, there are even more machine learning services and frameworks out there.
We thought 5 was a lot, so we stuck to 5.
Yeah, and these are some of the most common use cases that we see out there in the world. So we figured by showing these, hopefully you'll be able to get started. But that's pretty much it for us here. But outside of this, we do a bit of Twitch streaming, right?
We do. You can find us on twitch.tv/AWS with technical content, live coding, and even talking to startups.
Yeah, so thank you again for having us here at ByteConf. We're super excited to be able to talk to you about this. And hopefully we will catch you around in the chat
on Twitch.
Or on Twitch. Or you can always ask us any questions on Twitter. We'll be happy to respond.
And we'll make sure to post the GitHub inside the chat.
Yeah. Awesome. Thank you again for listening, and we'll see you around.
Thanks, guys, for joining us.